Hey everybody, what you have here is a clip from a bigger lesson on multiplying and dividing rational expressions. In this, you're going to see a few examples of some rational expressions you have to multiply or divide. This clip is intended for if you're looking for a little bit of a check, something to work through with some completed solutions, or just to clean up a little bit of theory you've had after doing some practice. Okay, I hope it helps. Okay, what I'd like you to do is I would like you to go through, copy down expression in C, and then I'd like you to work your way through and simplify. I think we have enough to go through and tackle this on our own. Okay, pause it now. Okay, we're back. So this should just be a matter of confirming our factoring. And you'll notice that the speed at which you can factor is going to significantly affect how long each one of these problems takes us. But if over the years we've built up a good factoring base, we should be pretty quick. Okay, now we get to that point. We notice we have multiply in between, so now it's time to try to cross-reduce. I have an x minus 4. Those can divide out. Ooh, I have x plus 2s. Those can divide out. And I have x plus 3s. Those can divide out. So in terms of my solution, the only things that couldn't divide out because they didn't have common factors were my x plus 1 and my x minus 1. Nice. Okay, we're not going to forget about our restrictions. And so for us to go through and tack on our restrictions, we need to look at our first factored form. And so we're going to tack on that our x cannot equal -2, 1, 4, or -3. We don't care what order you write your restrictions in. They don't have to be in increasing order. Put them down in any order and you're good. Okay, hopefully that one wasn't too bad. Notice it was mainly about factoring. Okay, we're going to jump in and tackle another. Okay, you take a look at D and you notice that all that's happening is our expression is getting a little uglier as we go. Okay, I want you to tackle the same thing. So I want to go start to finish on this one. So pause the video now. Yeah, okay, we're back. So we're going to have a fair amount of factoring to go through here. So let's take a look at the first one. So two numbers that multiply to give 6. Two numbers that multiply to give 1. I need a -5. So I have a 3y minus 1 and a 2y minus 1. Now, my advice to you earlier was try to use the factors that are present to go on the hunt to find other factors. Now, the problem with this is as we get more and more fractions or more expressions, it can be difficult to do that. So my focus to you would just be, you know what, just straight factor each individual expression, almost not even paying attention to the other expressions. So I now need two numbers that multiply to give 12, two numbers that multiply to give 2. If I do that, then there's a -8 and a +3. That can get me a -5. Now, I'm going to write something down, and I'm going to recommend that you don't do this. There's my divide by, and now I go to factor my next. Here's the reason why, is that if we start to write down that other fraction and we're able to factor it, then we may start going, oh, okay, so now I can divide this out, and I can divide this out, and then, oh, there's one of these here, one of these here. And we get so focused on the factors that we forget we have a division in between still. We can't divide out common factors, at least not across our fractions. So my suggestion to you would be don't factor it. Don't blindly copy down that division. I think what we could do is we could factor the second fraction and flip it to a multiply at the same time. So I'm going to look to factor the top of my second fraction. Two numbers that multiply to give 3, two numbers that multiply to give 1. I need a negative 4 in between. Now, you can see my mistake. That I switched it to a multiply, but I didn't flip my fraction. You're going to find that with practice, you're not going to make that mistake. That you're going to be focused in saying, okay, so I'm factoring the top. I flipped it, so let's write those factors on the bottom. Okay, now I'm factoring the bottom. Two numbers to multiply. This becomes one of those ones where I know pretty quickly I can't use 2 and 2 because my middle term is odd. So I've got my 4 and my 1 and my 1, and a positive in both cases. That is me factoring the bottom, so when I flip it, I know it's got to go to the top. Okay, I get something like that, and now I'm on the hunt to try to divide out common factors. I've got a 4y plus 1 on top and bottom. I notice I have a 3y minus 1 on top and bottom. I don't have anything else in common. I know that I do not have to expand this because nothing is going to simplify after that, so I can leave everything in factored form. There we go. Okay, I know we didn't forget about our restrictions. And the weird part is, just take a look at your notes. Did you write x can't equal? Like we almost didn't pay attention to the fact that there are no x's in this expression? That really what we're talking about is y's? So make sure that we have y that can't equal. And we are scanning our way across the bottoms of my fraction. So my first factored form, that 4y plus 1 is going to give me a y value of negative 1/4 as a restriction. My 3y minus 2 means that y can't equal 2/3. My 3y minus 1 means that y can't equal 1/3. My y minus 1 means that y can't equal 1. And then we didn't make the mistake. Look back up to what that original expression was. It was a divide by. So that means that I also need to take into account the top, all parts of the second fraction. Okay, all parts of the divisor. So I'm fortunate, 4y plus 1, I've already taken into account that restriction. However, that would have been the restriction that we probably forgot. I noticed from that factor that y cannot equal negative 1, so I'm going to change that to a plus or minus 1 in my restrictions. There we go. Hopefully not too bad. So again, it's really just factoring. And then after we get really, really good at factoring, now we can divide out common factors. Okay, let's keep it going with another. So I'd like you to do the same. Let's copy down that problem. You give it a shot on your own. Let's use this one as a gauge. Are we comfortable with going through and dealing with multiplying or dividing our expressions? Okay, pause it now. Okay, we're back. And so, as I stated earlier, we should just be good to catch up with factoring. Two terms on top, I have a common factor of 3x, so I can factor that out. Two terms on the bottom, I have a common factor of 4, so I can factor that out. I'm going to change that to a multiply so I can cross-reduce as fast as possible. Now what that means is I'm going to factor the top, and I'm going to make sure that that top goes down to the bottom when I factor it. So I can common factor out a 9 and an x, and that leaves me with an x minus 2y. And now on the bottom, that will then become factored onto the top. I can common factor out a 3 and a y, and that leaves me with an x plus a 5y. Okay, I can go through now and I can divide out my common factors. Well, I've got an x minus 2y and an x minus 2y. I've got an x plus 5y and an x plus 5y. And then I've got all these coefficients. So A 3 will divide out of that 9 3 times. But then the 3 will divide out of that 3 once. And then I've got my x that divides out with an x. Wow, that's a lot of things crossed out. Hopefully we can see through all of that and notice that the only factor that's left on top was a y, and the only factor left on the bottom was a 4. There we go. Now we didn't forget about restrictions, so I'm looking on my denominator. 4 doesn't give me a restriction because 4 is constant. It can't be made into a 0. However, that's going to give me a restriction that x cannot equal negative 5y. My 9 has no problem, but my x is there, so that tells me I need a restriction that x can't equal 0 as a constant. There's my x minus 2y, so that tells me that x cannot equal 2y. And because we were dividing, I've got to look at all parts of that divisor. The bracket there, I've already taken that into account. My 3 is not a problem, but maybe we can see through all of that mess, that y that I'm boxing in. That would have been the one that we probably, and I need to mark that as a cannot equal. That y would have probably been the one that we missed. There we go. I think we're doing great. If we got down to that and we have that one perfect, I don't think there's going to be much that I could throw at you that will cause you problems. So let's leave you with one last one. It's going to look a little ugly when you look at it. It's not bad. Here we go. Yes, I understand that now I'm asking you to multiply and divide within a problem. So now we have 3 fractions, but I think you should be good for this one. So same thing, copy that down, full solution. We'll see if we match up. Pause the video now. Okay, we're back. So again, we're just confirming some factoring. Common factor of x, I have a trinomial. Difference of squares, common factor of x. I'm going to flip and multiply that one. So my top goes to the bottom. That's actually a perfect square. 2 numbers to multiply to give 1 and add to give 2. My top actually is a perfect square as well. 2 numbers to multiply to give 4 and add to give negative 4. Okay, everything is fully factored. Now I'm going through to try to divide out common factors. Well, I've got that single x and that single x. Those will divide out. I have an x minus 1, and on the bottom, I've got 2x minus 1s. So I can divide it out of there. I have a x plus 1 and an x plus 1. I also have another x minus 1 and an x minus 1. And now I look, well, my x minus 2s, I've got a bunch of those. So I've got my x minus 2, another x minus 2 that will divide out with both of those x minus 2s. I got everything that all divided out. So I'm left with 0, nothing left. Okay, I'm hoping that you just caught that error. Remember, when things divide out, we're left with 1 because we're dividing something by itself. Hopefully you got down to 1 as your final solution. Now we just got to knock out all of our restrictions. So we've got x cannot equal, and I'm just going to work left to right, taking into account all parts of any divisors. X can't equal 2, negative 1, 0, 2, 1, and on top, 2 again. There we go. I can get rid of that comma at the very end, and we have every restriction included. Nice. Okay, I think that all you're missing now is just getting some practice and trying to drill this in to the point where you almost don't even have to think about it. That it just becomes a mechanical process for us to be able to go through and simplify. Okay, jump into your practice. Best of luck.